In the last video, I talked about how it's a rule of math that if x is approaching 0, this becomes a 0 over 0. You can't do it that way, but we found with a proof back in the history of mathematics that you don't need to know right now that this is true. Sine of x divided by x will have a limit of 1 if x is approaching 0. But there's another rule that I want to harp on here, and it's important to look at because it's a very similar one that comes from the same place in the same proof that you do not want to spend time looking at when you're learning calculus. Maybe do it later, unless you're a masochist and you like pain. Okay, and there's another way to write this if you want. And I'm going to make the positive version of it, just because it's more common. 1 minus cosine of x over x squared is equal to 1/2. And the only reason I bring this up is I'm seeing it in this second problem set here at least once. So let's just have it available to us here. Okay, now the first problem, that's a little more obvious because we've done this a time or two, right? Sine of 4x over sine of 6x. We want to find it as the limit when x approaches 0. We're not doing derivatives, right? We're doing limits. We're trying to find the value. And this would be 0 divided by 0, which is a meaningless thing. So we're going to do these rules to play with it and see if we can come up with a different answer. So for this guy, I'm going to put a 4x over 4x in front of him and a 6x over 6x in front of him. And immediately, I hope you would recognize that it's because we want to cancel out the top and bottom of what we have here. And what I end up with is 4x over 6x. Well, those cancel and you get 2/3. So it's no longer 0 over 0 because we've applied a rule of math that let us cancel things out. This is really cool. We're going to be doing it a lot in calculus, applying rules that lets you hop over the problem instead of going through it. I don't know if you know that old grade school chant. Can't go around it, gotta go under it. And now look what we have here. It's like I prepared for this one. Cosine. Whoa, what happened there? Cosine of x minus 1 over sine of x. It's a theta, but we don't care. It means the same thing. It's some variable. Well, we know this is the rule we want to play with, right? So let's take this here, and we'll multiply by x squared over x squared. And same here, we'll do x over x. You know the drill at this point. So this will be negative 1/2, won't it? So we're going to get negative 1/2 x squared divided by x, because this cancels out as 1. Right, so let's bring the 2 down here, and we're going to get negative x squared over 2x. Obviously, an x cancels out, so I think it's going to be negative x over 2. And that'll be the answer for that one. Of course, you might want to write it as theta over 2, because that's how the problem is constructed. What's the next one look like? See, we're just doing algebraic substitution. What is theta, by the way? It's 0. Right? So this is a big fat 0. Now you wouldn't know that when it's 0 divided by 0. That can mean anything in calculus. That has no meaning. It does not mean infinity. It does not mean 0. It has an empty meaning. Okay, the next one says sine of 3x sine of 5x over x squared. Now we can make this, instead of x squared, I'm going to make it an x times an x. And then we'll put a 3 on top and a 3 on bottom and a 5 on top and a 5 on bottom. And you see why. So we get 15. And then this 3x and sine are gone. And this 5x and sine are gone. So I believe our answer is going to be 15. That was a good one. I like that one. I'm happy to have that one. Who's next? on the docket, the last one on this problem set. Can we do it quickly? I'd like to do it quickly. Let's see what happens here. Sine. Remember again, x has to be approaching 0. They'll trick you on a test where it's like approaching 1. Some of the problems will say that, and you'll miss that, do the problem, and you'll miss the whole point. Okay, what are we missing? The inside of the sign and the denominator do not match. We need them to match, so we got to multiply by an x on top and bottom. And now this cancels out, and we just get x. And what is x? X is 0, so our answer for this is going to be 0. And that's it. That's how you apply these rules. I'll try it again in the next video.